and welcome to Show's classes. Today we are going to be dealing with some very difficult yet easy questions of econometrics. You can call or WhatsApp at the number given on the screen for any doubts or full videos on our course. In this question we have a regression model yi equals to beta 1 plus beta 2 xi plus ui, where yi equals to capital yi minus y bar and small xi equals to xi minus x bar. In this case, the regression line must pass through the origin. We have to determine whether this statement is true or false. This statement is in fact true. Note that the usual OLS formula to estimate the intercept is beta 1 cap, which is equals to mean of the regressant minus beta 2 mean of the regressor. But when y and x are in deviation form, their mean values are always 0. Hence, in this case, the estimated intercept is equals to 0. Moving on to another question. We have the following regression model: 1 by yi equals to beta 1 plus beta 2 1 by xi plus ui. Note, neither y nor x assumes 0 value. We need to determine whether this is a linear regression model. Let's do number A. Since the model is linear in its parameters, it is a linear regression model. Now in the next case we have to estimate this model. I'll clear this. For this, first we define capital Y star equals to 1 by capital Y and X star equals to 1 by X. And now we do an OLS regression of Y star and X star. Now we have to figure out what is the behavior of y as x tends to infinity. Therefore, as x tends to infinity, y tends to 1 by beta 1. Now let's do number B. Can I give an example where such a model may be appropriate? Let me do it out here. This model may be appropriate to explain low consumption of a commodity when income is large, such as an inferior good. Now, since this question is solved, we'll go on to the next one. Now we have a graphical question. We consider the log linear model ln yi equals to beta 1 plus beta 2 ln xi plus ui. We have to plot y on vertical axis and x on the horizontal axis. We have to draw the curves showing the relationship between y and x when beta 2 equals to 1, beta 2 is greater than 1 and beta 2 is less than 1. Notice from the equation beta 2 is the slope of our equation. Let's see. These are the three cases. In the first case, when beta 2 is equals to 1, it is a relatively standard sloped, positively sloped line. The second figure, beta 2 is greater than 1, it is an curve, increasing curve with an increasing and a relatively lesser dmu. For the third one, beta 2 is less than 1. Let's see the next question. This is a very important sum. We are given model 1 and model 2. Yi equals to beta 1 plus beta 2 xi plus ui. Yi star is however equals to alpha 1 plus alpha 2 xi star plus ui, where y star and x star are standardized variables. We have to show that alpha 2 cap is equals to beta 2 cap sx by sy, and hence we have to establish that although the regression slope coefficients are independent of the change of origin, they are not independent of the change of scale. Let's see how to do this. For model 1, we know that beta 2 cap is equals to summation xi yi by summation xi square, where x and y are in deviation form. For model 2, we have alpha 2 cap equals to summation xi star yi star by summation xi star square, which equals to summation xi by sx into yi by sy whole divided by summation xi sx whole square. This in turn equals to summation xi yi by sx sy whole divided by summation x square by sx square, which upon simplification comes to sx by sy beta 2 cap. I'll show you how I've origined this from this. Sx summation xi yi by sy summation xi square, and as we have seen, the formula beta 2 cap is nothing but this portion of the formula. This shows that the slope coefficient is not invariant to the change of scale. That was the end to our last question. With this, we come to an end of another great video. Please like, subscribe and press on the notification button. You can contact us in the given number for any doubts or full videos on our courses.